Birmingham sound reproducers produced record changers on contract, but they did also produce some standalone products under their own brand. Brands like BSR McDonald, the Lab and Quanta series being the most notable, they all used the same mechanisms, but the difference is they were specifically branded as their own product. I'm Kerry Gray, and this is Stranger's Things, Vintage Electronics Edition. BSR produced less than half a dozen different mechs, as we call them, or mechanisms. Then OEMs could then choose their base styling. They could also select which tonearm, control setup, overarm features, and other adaptations to the look and feel of the table to help differentiate their particular BSR from a competitor's model. It was strictly a la carte, sort of the McDonald's, no relation, of mechanical changers of the era, but they could stamp them out by the millions. It's this reason, or for this reason, why decoding the red tag, which is the tag under the mechanism, which is the data tag, so it contains all the information about the mechanism, the base it went into, and the OEM that contracted them to build a specific aesthetic. Unfortunately, BSR didn't leave much behind, if any, in the way of historical records when it went TU in 1985. Well, in 1967, when BSR really entered the global market with mechanical changers, they debuted with the 100 series. The 100 series continued all the way up into 1975. So that's is that an 8-year run, pretty much? And there were several revisions along the way. The 110, the 111 came in 1969, 2 years later. The 129 the year after. And these were variants of that original model, the 109, that just incorporated minor mechanical improvements. In 1972, the C142 and 143, but this time the tone arm had some refinements. So what are we going to talk about today? We're going to talk about this guy. This was produced for the OEM Soundesign, has a Soundesign base and plinth all together, but the turntable itself is quite clearly a BSR, an a la carte BSR. On the red tag on the bottom, the base model of the mech is C141. So going back to the timeline, the C141 was produced in 1971, give time for the supply chain to empty out. So probably 75 or 76 before all those 141s were flushed out of the system and ended up with the end consumer. Very common changer. We're gonna hope that this guy doesn't need a lot of work so that we can limit the amount of restoration to what we call internally as a light restoration, all that's necessary to make it work as intended. Otherwise, the price on the secondhand market, the retail price, would be prohibitive. This is more than half a century old. We just put it on the bench. The only thing that I have done to it, so we're going to do this together, is I've removed the bottom. I've checked the cordage, and the reason that I do that is to see if I have any problems underneath there. And what I found underneath was dust-wise pretty clean. You know, a couple of dust bunnies here, but that's about it. This one's clean. This is very clean, and it looks in pretty remarkable condition overall. Again, we haven't detailed it, we haven't cleaned it. Obviously, it's old, but one of the things that I noticed right away is that the protective plastic on this center aluminum ring and the inner beauty ring, that's still there. It's kind of crumbling in pieces, but the protective plastic is still there. It means when I remove that brushed aluminum look is going to shine because it hasn't been oxidized over the last half century. But I'm putting it on the bench for the first time. We're going to fire this up and we're going to see what happens. We're going to use our Thrasher record here. We're going to be looking and listening for the idler. The idler is the wheel between the motor pulley and the rim of the table. Is that idler soft enough to transfer torque? Or is it too hard? Is it out of round? Or worse, was it left on and engaged and now it has a dent in it? If we see that the table isn't turning very well, that typically means the idler is going to need some work, and that's going to affect the next thing that we're going to look for, which is the condition of the cam. So the cam is responsible for engaging the automatic features of this changer. The controls are also greased with that same grease that you can bet is dry. We saw a little bit of it when I flipped it up. It's a little dry, which is common. The spindle, this guy here in the middle, probably the most important is the tone arm itself. We can already hear the cartridge works to some degree because it's picking up the microphonics of me handling it. But will the tone arm move? Will the tone arm drop in the right place? Most importantly, when I reject, will the cam engages again, and will it go back to its rest post? So let's find out. The control snapped back, and that worked. The turntable is moving. Oh, this is pretty encouraging. Drop down in the right place. Being a ceramic cartridge, you don't need a preamp or RIA equalization. So you can just plug it into line in, which is what I've done. I'm actually pretty impressed. The table turned. It didn't need any help from me. The mechanism went all the way down to auto, because it's in auto mode, and snapped back to start. So I'm going to say this is running about 34 to 34.5 RPM, but it's got torque. As we saw, I didn't have to help the turntable turn. Those are very good indicators for the condition of the idler. And for a 50-year-old turntable, having good rubber on that idler is the heart of the machine. Without an idler, you just have BSR parts for sale. Now, rubber can last a very long time, decades and decades and decades, if it's cared for. You must treat that rubber with oil of wintergreen, or you're going to be fabricating your own. Nobody really wants to do that. And there are several products, not plugging them, I don't make anything for it, but I recommend Rubber Renew, which is oil of wintergreen and a catalyst, obviously, to carry that, clean the rubber and carry it into it. So based on what I'm hearing so far regarding the idler, I'd say it's a very good candidate for a light restoration. Let's finish out the rest of the controls. By the way, the idler, or the spindle also worked because it dropped the record nicely. So let's try and reject this. You heard it come down a little bit in pitch, and that's normal on a mechanical changer. It returned back to the rest in the right position very nicely and shut itself off without any help from me. The pitch that you hear, that is normal. Remember, as I discussed, the platter is engaging a cam. It's not uncommon if the needle is still on the record, which it is in a reject situation, that you're going to hear the pitch drop. Even fully serviced, you're likely to hear some level of the pitch drop when you reject. A little sticky on that control. I noticed that coming to the auto was a little sticky, but the spindle mechanism retracts back. It lands beautifully. I'm not even going to have to adjust that. Let's find out if our tone arm lift seems to work beautifully. And now what we're going to do is we're going to see if it will reject itself on the lead out groove. And on the lead out groove here, it's sort of a rule of thumb. And you're not going to be able to see this, so you're going to have to take my word for it. But we want the tone arm to pick up about halfway through the lead out groove before it hits the label. And it does, it picks up just a hair past the halfway point. So the adjustment for lead out and lead in actually look really good. When it comes to vintage gear, how it was taken care of means something, because that's going to dictate the scope of our restoration. But also, it tells a little bit about the person who owned it. That helps a lot on the secondhand market. All right, next up in the topside test here is going to be record sizing. So we were at 12, I've reset the record, and I'm going to move it down to 10 inch. And so on 10 inch, we should see the tone arm come in, you know, about 2 inches further in. Makes sense. Looks like it does. Let's reject it. Shuts off nicely. I'm gonna set this down to 7 inch, which would be a 45. So let's see what it'll do for a 45, where it should move about 2/3 of the way in, and it looks like it does. So it lands nicely. I've done this enough to know that that is pretty much right on where it should land for a 7 inch record. So it looks like our record sizing is not giving us a problem. I'm not going to hold out much hope for speed change control, which is this control. As I go up, I think I'll be fine. As I come back down, I don't think that's going to be quite as smooth. So let's go up the scale there, and we're at 33. Theoretically, that's 45. I have a sense that might be a little bit faster than 45. It'll be interesting when we put the meter on that, but at least it gets up there. Now we're going to go up to 78, which sounds about right for 78. Now as I come back down, I don't think it's going to be that smooth. I just have a sense that it's going to be a little sticky. Take it back down to 45. When I came down to 45, it wanted to go on. You probably saw that I stopped it there, so that is about what I would expect. I brought it down one notch to 45, and it wanted to keep going, which means that the step cam there isn't engaging fast enough to stop it. So we're back down at 45. When I go to 33, I'll bet you right now it's going to go all the way. It's going to want to continue all the way down to 16. We'll find out. Yeah, it wanted to fall to 16. How this works is the idler moves up and down on a step cam, and that cam is slow, gunked up by grease. It's not going to get the stop in place in time to keep it from wanting to go all the way down the scale. Not a big deal. We're going to clean that grease anyway. And then let's take a listen to 16. Sounds about right. Might actually sound a little slower, but we'll put the meter on it and we'll find out. So far, I'm going to say this looks like an excellent specimen. And what that means, bottom line, is I'm going to be able to go through it very quickly, and it's going to be right as rain. It's going to be ready to rock and roll. We'll leave it to the buyer to take it any further if they want to do that, because then we'll be able to price it right to move it, which is what we're all about. In looking at the top side and giving it a quick scan, it appears to have all its parts, which is good. Okay, the last thing we're going to do now before we go to the bottom side, we are going to do a speed and wow test on the various speeds, just to kind of get a baseline of where we're at, and then we can compare that to the specs if they're known. And other than that, we'll just have to use our own experience and where we think it should be. I just finished doing the speed test, On 33 1/3, pretty close. That came out to be 35 1/2. 33 1/3 is ideal on these changers. That is an ideal. It's always going to be, on any idler changer, it's never going to be 33 1/3. Idlers have some pros and cons. That's one of the cons. And if you want exactly 33 1/3, to move to a direct drive, but it's always going to be a little goofy without any sort of control, and especially on an idler. But anyway, so it was a little fast. I was right on that. We moved up to 45, and I said, that sounds even faster to me. I was running at 49 RPM. That's quite a bit faster. So at 78, it was running at 81. And so quite a bit faster. At 16, that's one of the closest. That's running at 17 1/2. I believe I said it might be too slow, and it was pretty much right on, actually, very right on. The wow factor in this usage, that doesn't mean good, like the wow factor. No, in this case, the wow factor is all over the map and not really that good. With a BSR, you get a wow of 0.2, taking it out to 2 sigma, which is what I look for. That's a longer period of measurement than just a quick snapshot. For a BSR, 0.2%, that's about as good as you're gonna get, especially on a 50-year-old idler. All due to just needing rehab. I've seen those numbers before. They don't scare me. Next segment before we go to the bottom. Even the overarm is a little sticky. The overarm has 2 critical points. It can't go down so far that it goes past the mechanism. And the other metric is the speed of the drop. From what I can feel, I don't think we're gonna have an issue there either. And this is a metal overarm, so that definitely harkens back toward the earlier 70s before they moved on to plastic. If you have to tap a little bit on the spindle, then you can presume that you have a grease problem throughout. It came out. Can I get the table off? Wow. Very, very encouraging. So here's our idler, and yeah, that's beautiful. Just squeezing the idler, that should give way under my fingers without much pressure, and it does. So this is going to clean up quite nicely when it's treated. If I spin it, I can kind of get a visual idea if it's out of around. Also, I don't see a dent, and the dent, and I'm using my finger right now to feel for it, because you can typically feel it. Once you feel it, then you can visually see it. And I don't feel a dent. I do feel that the outside is a little bit dry, so there's some dead rubber, which I would expect. But the dent comes from someone leaving it in the engaged position. So they unplug it, they leave it in the engaged position, and it stays like this for decades. And eventually the spring pressure against that pulley of the motor is going to create a dent as that rubber dries out. That would be bad. I don't feel it, I don't see it, so we'll be fine just cleaning that up and reconditioning it. The pulley here on the motor, oh wow, that is one dirty pulley. Looks like the dried rubber has already transferred itself to the pulley. That's creating our wow and why we're running fast. Speed is a function of the ratio of the pulley diameter and the inner lip of the table, that diameter. It's that ratio that determines speed. So it was creating a fairly uniform buildup, but that increases the diameter of the pulley, so that actually speeds it up, because now it's changing the ratio between the platter and the pulley. The idler contrary to what some people may believe, has nothing to do with the speed. That can be any size, but it does have a lot to do with the torque. So obviously, as that pulley would get thinner, the angle of attack is going to change. And when they engineered it with a very specific angle of attack to transfer the most torque possible from the motor pulley to the table. So if this gets worn down too much, the torque transferred is going to start coming down, and that's going to cause more drop when you reject and the cam engages. You're going to hear more of a pitch change as that torque drops. So that would explain our much higher RPM. Once I clean that up, it'll be interesting to see what it drops down to. I would definitely expect it to drop. This is the cam that engages all of the automatic functions, and it is heavily greased, but I can actually turn it with very little tension right here before it engages. That's good. This is the mechanism that kicks the pawl that comes over from the tone arm and kicks this cam to engage with the table as it's being turned by this idler. But this mechanism needs to kick that in order for it to catch it, and it does that with the position of the tone arm, or if you manually reject it or start it, it'll kick that. And that kicking will cause this cam to catch on that gear that's rotating, because the motor's rotating the platter, and it'll spin it around, and that's what causes the automatic function until it comes back to rest, waiting for that mechanism to kick again. Why that's important is this mechanism needs to move freely. Looking at the spindle itself, the shaft, I don't see any scarring, and that's good. Underneath that is the bearing stack, and that's going to get a deep clean, but I gotta tell you, other than at the bottom where I can see the dry grease, that is in really remarkable condition. Sometimes BSR was pretty heavy-handed with the grease. This one looks like they were pretty light-handed. Rubber bushings on the mounts, we always treat those as well, motor mounts, with rubber renew, because they are key to keeping the rumble down. All right, here's the underside. I love wooden bases because I can set it up without needing any support. And the bottom side, other than a few dust bunnies, really the only thing that jumps out is dried grease, which you can clearly see. These are the linkages from the mechanisms that we talked about. This is controls the speed, and as you can see, it moves up and down on this step cam. And you can see when I go from 78 down to 16, there's a spring here that should be pushing this white down the cam, and you can see it's damp. It's very slow. So it should function more like this, like that, as I go down the steps. In this case, once I go to the next one, there's a marked delay, and because it delays, it doesn't catch the next step. Very, very slow. Not a big deal, that's just grease, but all of that will have to be re-greased, so that's the speed changing mechanism. By the way, these wires are all very supple. Another good sign it was kept in a good environment. So all of even the original cord, which we like to leave because it goes with the aesthetic, is in very supple condition, so we won't have to deal with that. The on-off reject mechanism is this guy, which will bring the idler into contact with the motor pulley, but also down here, it's what's responsible for cueing. You can see that lever slide. That's the pawl that kicks that mechanism into the cam. And you can even see it's got a little bit of it doesn't want to come back necessarily on its own. It's very slow. So there are very few grease points, and this BSR, even though you can see the grease, this is, in my experience, this is one of the lighter greased ones. These require very little grease, especially if you're using modern grease lubrications like Phonolube or Superlube. They just need enough grease not to catch on the metal they're rubbing against, not to catch. They don't need it to lubricate the movement. Like here, the reason it's so hard is the grease there is actually causing resistance against my hand. So that makes that very difficult to pull down into the reject mode. So the tonearm neck, this very thin wire here is the anti-skate. And the reason for that is in physical laws, the tonearm moves toward the center of the energy. That's the center of the record. It's going to want to naturally gravitate toward it even faster on its own. The closer it gets to the center, the more of that energy wants to pull it toward the center, and that causes distortion and mistracking toward the inner tracks of a record. In the 50s, they didn't really have that, but they had mass. So they had so much weight on the needle that even though those forces were still at play, they weren't enough to overcome the sheer mass of the head shell. In the 60s, when lighter and lighter mass head shells and cartridges, you've got to have some force acting on that tonearm to keep the needle in the groove where it should be and not being drawn toward the center. That's what this wire does here. This is basically a spring wrapped around, very simple design, and depending on where you set that on the top side, that's going to determine the max amount of grams acting on that tonearm the closer it gets to the center to pull it back and stay within the groove. Probably a very oversimplified explanation, so you want to be careful when working around that you don't distort it or lose it, because then you won't have any anti-skew and you'll be forced to use a 5-gram cart, which is going to ruin your record. It looks right now, to sum all of this up, that all we're really going to do is a light cleaning at this point, or a light servicing, I should say, which means that we're not going to disassemble this mech, because that's going to add time and that's going to add cost. But we're going to clean up all these grease points with isopropyl alcohol and get all that grease off. Then we're going to re-grease all of it with Superlube, and we're going to re-lubricate these points that you see in brown, and then we're going to deox this switch the best that we can. Our connectors, they all need deoxing. They're 50 years old of oxidation, and we want the best possible result that we can get from it. We don't see any crud built up on any of the mechanisms, no corrosion on the motor here, and this is another indicator that this is a very early model, because like I said, they didn't improve the motor, and by an improved motor, I'm talking about a 4-pole motor. They didn't do that until 78. But yeah, other than quick deox, quick clean, quick lube, lubricate the motor, and then treat the rubber points with rubber renew, and then we go to the cleanup and the detailing of it to make it shine. But we're gonna separate these two, get a picture of the red tag so we know what we're really looking at, and then get started on the cleanup, which I will film as I'm doing it.